You got 2.6, there you go. Divided by 1,000. You're right on my table, man. Yeah, I understand, but you want a big piece of paper to put on the table? You scribble on it all day. Every time I see molarity, I call Alright, raise your hand if you'd like more time. Alright, I can't give you more time, I don't have any to give, but I'll give you a moment to finish this problem. Don't have any more time left. Alright, we need to speed up time just a little bit, so let's check and see where we're at with this solution. First thing to know, molarity is moles per liter. So you've got 2.6 moles per 1,000 liters, or 1,000 milliliters, pardon me. Then you take 150 milliliters times 2.6 over 1,000, you get 0.39 moles of the lead nitrate here. Now, molarity is 2.6, it limits it to 2, that's why you got 2 sig figs in your answer for A. For B, once you have the moles of the entire thing, all you need to do is keep track of the nitrates. So how many NO3s are there in this? 2. 2 of them. So, 0.39 times 2, 2 moles to 1 mole. We've got 1,000 milliliters divided by 1 liter, and then 1 to 150 gives us 5.2 molarity. So you go, okay, I can get the moles pretty easily, then I can convert it into liters. Now, you may notice something about this number here, 5.2. This is just what that? Just twice that. So if you use the molarity ratio, molarity to molarity, because moles, the mole ratio and the molarity, or the molar ratio, works out just great because you're not changing the amount of solution. Now, solution's staying the same, so the moles can't change. The volume can't change. The moles per liter can't change. So that's why 2.6 times 2 over 1, boom, you're done. That's the cool thing about moles. If you don't see that, you go through the extra steps, because molarity is always moles per liter, but it can also be a very quick ratio. So when you have the molarity, it helps you out there. This is a very convenient way for working with chemical equations. You can see the mole ratio, you can see the molar ratio. The mole ratio and the molar ratio are the same as long as the volume stays the same. If the volume doesn't change, you're totally stoked. If the volume changes, then you got to do some more work on the calculation, and that's not a problem. Second way, mass percent. Mass percent is the mass of the solute divided by the mass of the solution. Once again, not the solvent, times 100%. To get the mass of the solution, you just take the mass of the solute plus the mass of the solvent. And these here are mass percent. Oh, there we go, are some important equations that can be used as well. Molarity is definitely used on the AP exam. Mass percent can be used and is commonly used in America. So if you see something that says it's 91% isopropyl alcohol, is usually done by mass and not by volume. Although there are some uses. It's usually the easiest way to measure it, because you can measure the substances before they go together, and that gives you your totals.
What's the difference between mass solution and mass, like, percent?
Mass percent, this is a way to calculate it, and to get the mass of the solution, you have to add the solute plus the solvent to get that.
I'm guessing it's more likely to use it.
Why you would use it? You could do a volume percent as well. It's another option. So you would do everything based on volume. The reason we do it on mass is it's much easier to have an electronic balance measuring things as they're going to be put into substances. So this is why your box of Cheerios says it's measured by weight, not by volume. Okay, just because it looks like you didn't get anything in there doesn't mean it doesn't have the same mass. So most things in America are measured by masses only. So mass percent is commonly used. There are advantages to volume percent, but it's harder to measure in the first place for most substances. So if we had a solution of 31.7 grams of silver nitrate in 52 grams of water, what is the mass percent? That will give you a minute to calculate it. It might take you less time. You've got 50 seconds. If you're done, just say yes. Use the equation, just write it down. All right, you still have 30 seconds if you want to continue to work. For everybody else, you can check our answer. Mass percent, mass solute over mass solution. All right, next one. ppH. ppH is the decigrams of solute per kilogram of solvent. ppH, parts per hundred. Now, 1 gram is equal to 10 decigrams. Deci is smaller than the gram. So you need 10 of the little ones to make one of the big ones. Parts per hundred is not on the AP exam, but it is on the CST chemistry exam at times. Yes, sir. Yeah, good question. I'll have to look at those notes. So if you got 1 gram, that's 10 decigrams. 1 gram is 0.001 kilograms. 10 divided by 0.001, is that right? Oh, I'm sorry, 0.01. 0.01, huh? Yeah. I would agree with you. I'd have to look at this. Parts per hundred. This here was in our notes. Parts per hundred usually. Yeah, I would take 37.9 times it by 100. Usually gives you the right answer there. Now, I've seen it on the chem exam 0 times before. CST chem exam, but parts per million is more common. Let's hope this one's right. Milligrams of solute per kilograms of solvent. This one is also not on the AP exam, but this one is more likely to be on the CST chemistry exam. So you need to be aware that there are different ways of measuring using concentration. Parts per million is often used in atmospheric chemistry, or parts per billion, depending on the amounts you're dealing with. Yep. I believe the DG looks wrong to me. Well, I will look into that and clarify that for you guys. Mathematically, it looks wrong to me. I don't want to pick it right now. It's not on the AP exam. I don't even want to think about it anymore. You can fix it at home. You can do research on it. You can report on it. Now, this here is on the chemistry exam. It's in green. That means it's good. It is the mole fraction. Mole fraction is a very easy way of determining a concentration. Oh, there we go. You take the moles of a certain substance divided by the total moles in that sample. And it gives you a fraction or a decimal of how many moles you have in that particular sample. It's very commonly used to determine amounts. And it is an easy fraction to use. It's used in gases oftentimes. The last one here is molality. This is also used on the AP exam. Molality is equal to the moles of solute per kilogram of solvent. So instead of molarity, which is moles per liter, this is moles per kilogram of the solvent. So it's got a couple different things on it. It's only the solvent and not the solution. The relationship, 1 kilogram is 1,000 grams. Helps you convert to kilograms for the solvent in this case. The units are lowercase m or moles per kilogram. And this is abbreviated molal. This is called molal, not abbreviated. So, sample problem here, if you had 0.5 molal sodium chloride solution, that's equal to 0.5 over 1 kilogram of water, which is also equal to 0.500 over 1,000 grams of water. So these here obviously can be used to help you convert from molal to moles or to grams, or backwards. Now, to have a little more concentration, normality, which is uppercase N, is the equivalence of X. Now, X is a very specific amount, especially for a reaction. The equivalents of X are determined within the context of specific reactions. So it may not be a specific substance, it might be a group of atoms as a specific substance, or a certain type of molecule maybe. The units here are capital N, and a solution would be called normal. And the good thing about normal is it's not just on the AP exam. It's a little harder to define the equivalents you're talking about, and it's very helpful when you're working in certain laboratory situations, but the AP exam, they don't expect that to be known. Yes?
What unit is
X is usually, it might be like an ion, equivalent to a certain ion in solution, or it might be a particular, the unit of X is, yeah, it's not usually grams, it's usually amounts. Counting amounts, or sometimes it's milliliters or something. So it all depends on what is needed for that reaction. But since it has such variance, that's why it's not a common measure. I've used normality 0 times in my life. But I don't work in a chemistry lab in which they may use it every day. So it's just, once you have what you're looking at, it can have a function. Yes?
The equivalent of X are only specific to the reaction.
Yeah, specific to a reaction. Now, something that is commonly used on chemistry exams and AP chemistry exams is a simple concept that looks at concentration in a different way, and that's density. Density is defined as the mass per unit volume. Some things you need to know about density is the milliliters for density. Milliliters for density is defined as 1 centimeter cubed. This is the definition of a milliliter, so these can be used interchangeably, always. The units for density are grams per milliliter or grams per centimeter cubed. The second conversion factor for density that has to be known is that the density of water under certain conditions equals about 1.00 gram per milliliter. So if you're given a certain amount of water, you can determine its mass through the density, assuming certain conditions. So if they don't tell you the conditions, you can make that assumption that you got 1 gram per milliliter is true for water. Water is the standard for density for most problems. If you're given temperature or other information, that number is not always the answer. Now, if we look up here, if we have a particular sample that has a mass, so pick a number between 0 and 500. 25. Now, what's the molar mass of this compound going to be? Molar mass? 440? Sure, why not? Let's use the one we had here. So here we could determine the number of moles. So the first step is you determine the number of moles. And then to get the concentration, you take the moles divided by the volume. How much solution do we want to add to this? 44 milliliters. Oh, nope, 44 decimeters cubed. Ooh, interesting. All right, so this here is our concentration of this particular solution. Again, that's how you would make a solution, go through those steps. Now, if you want the mass calculator, you have a solution, has a certain concentration, certain volume. You can find out how many moles that is using the molar mass. That tells you how much mass you would need. So I would need this much mass to make a 2 molar solution of this particular sample. Now, when you dilute something, you are adding more solvent to a known solution. The moles stays constant. A stock solution is a solution of known concentration used to make more dilute solutions. So normally that is something you would get to make a new solution. Concentration always decreases in that solution. So when you add solvent, it decreases the concentration, but the mole stays the same. This here is called the dilution equation. This is the one equation you need to know to make a solution and dilute it. The I stands for initial, the F stands for final. So MI is molarity of the stock solution, VI is volume of the stock solution used, and MF is molarity of the new solution. VF would be the volume of that new solution. So M1 V1 equals M2 V2 is another way of writing this. This is the number one equation I use anytime you make solutions or deal with solutions. Number one. There you go. So volume comes from the stock solution. You add water to it, the final volume, the final molarity.